Welcome to Teachers. This is the first video on Class 10 Physics for the chapter Electricity. This is common to CBSE and all state syllabus which follows the NCERT pattern of curriculum. In this session, we will discuss electric charge, electric potential, etc. Subscribe to this channel for getting the latest video on physics and chemistry of class 10 and 12. Don't forget to click the bell button so that you get notified whenever a new video gets added. Electricity is an important source of energy in the modern times. Electricity is used in our homes, in industry, and in transport. For example, electricity is used in our homes for lighting, operating fans, and heating purposes. In industry, electricity is used to run various types of machines, and in transport sector, electricity is being used to pull electric trains. In this chapter, we will discuss electric potential, electric current, electric power, the heating effect of electric current, etc. In order to understand electricity, we should first know something about the electric charges. If we bring a plastic comb near some very tiny pieces of paper, it will not have any effect on them. If, however, the comb is first rubbed with dry hair and then brought near the tiny pieces of paper, we will find that the comb now attracts the pieces of paper towards itself. These observations are explained by saying that initially comb is electrically neutral, so it has no effect on the tiny pieces of paper. When the comb is rubbed with dry hair, then it gets electric charge. This electrically charged comb exerts an electric force on the tiny pieces of paper and attracts them. Similarly, a glass rod, when rubbed with silk cloth, and an ebonite rod, when rubbed with woolen cloth, also acquire the ability to attract small pieces of paper and are said to have electric charge. Let me tell you the reason for acquiring charge by certain materials, even though it is out of your syllabus context. According to the modern views, all matter is composed of atoms. Every atom consists of nucleus composed of positively charged protons and neutral neutrons. Around the nucleus, negatively charged electrons revolve in different orbits. Since in an atom, the number of protons are equal to the number of electrons, it is neutral. Hence, matter is said to be uncharged. Outermost electrons in an atom are called valence electrons, and in conductors, these are loosely bound to the atom. The excess or deficiency of electrons in a body gives the concept of electric charge. If in a body there is excess of electrons over its neutral configuration, conventionally the body is said to be negatively charged. And if there is deficiency of electrons, the body is said to be positively charged. So a negatively charged body means it has gained electrons, while a positively charged body means it has lost some of its electrons. Now we will discuss types of electric charges. It has been found by experiments that there are two types of electric charges, positive and negative. By the way, we have now come back to our syllabus. By convention, the charge acquired by a glass rod, that is when rubbed with a silk cloth, is called positive charge, and the charge acquired by an ebonite rod when rubbed with a woolen cloth is called a negative charge. An important property of electric charge is that opposite charges or unlike charges attract each other. For example, a positive charge attracts a negative charge. Similar charges or like charges repel each other. For example, a positive charge repels a positive charge, and a negative charge repels another negative charge. The SI unit of electric charge is coulomb, which is denoted by the letter C. We can define the unit of charge as follows. 1 coulomb is that charge which exerts a force of 9 into 10 raised to 9 newtons on an electric charge of equal magnitude at a distance of 1 meter from it. We now know that all the matter contains positively charged particles called protons and negatively charged particles called electrons. A proton possesses a positive charge of 1.6 into 10 raised to negative 19 coulomb, where an electron possesses a negative charge of the same magnitude, that is 1.6 into 10 raised to negative 19. It is obvious that the unit of electric charge called coulomb is much bigger than that the charge of a proton or an electron. Conductors and insulators. In some substances, the electric charges can flow easily, while in others they cannot. So all substances can be divided mainly into two electrical categories: conductors and insulators. Those substances through which electric charges can flow are called conductors. But the flow of electric charge is called electricity. So we can say that those substances through which electricity can flow are called conductors. All the metals like silver, copper, aluminum, etc. are good conductors. The metal alloys such as nichrome, manganese, and constantine, which are used for making heating elements of electrical appliances, are also conductors, but their conductivity is much less than that of pure metals. Carbon in the form of graphite is also a conductor. The human body is a fairly good conductor. Those substances through which electric charges cannot flow are called insulators. In other words, those substances through which electricity cannot flow are called insulators. Glass, ebonite, rubber, most plastics, paper, dry wood, cotton, mica, bakelite, porcelain, and dry air are all insulators because they do not allow electric charges or electricity to flow through them. In the case of charged insulators like glass, ebonite, etc., the electric charges remain bound to them and do not move away. We have just seen that some of substances are conductors whereas others are insulators. Now let us explain the reason for this behavior. All the conductors like metals have some electrons which are loosely held by the nuclei of their atoms. These free electrons can move from one atom to another throughout the conductor. The presence of free electrons in a substance makes it a conductor of electricity. The electrons present in insulators are strongly held by the nuclei of their atoms. Since there are no free electrons in an insulator which can move from one atom to another, an insulator does not allow electric charges to flow through it. Electricity can be classified into two parts: static electricity and current electricity. In static electricity, the electric charges remain at rest, or we say stationary. They do not move. The charge acquired by a glass rod rubbed with a silk cloth and the charge acquired by an ebonite rod rubbed with a woolen cloth are examples of static electricity. The lightning which we see in the sky during the raining season also involves static electricity. In current electricity, the electrons are in motion and those produce electric current. The electricity which we use in our homes is a current electricity. In this chapter, we will discuss only current electricity in detail. So, when we talk of electricity in these discussions, it will actually mean current electricity. Now we will discuss electric potential. Before that, let me say what is an electric field. An electric field is a region surrounding an electric charge where its electric effect can be experienced by other charged particles. So, when a small positive test charge is placed in the electric field due to another charge, it experiences a force. So, work has to be done on the positive test charge to move it against this force of repulsion. The electric potential or potential at a point in an electric field is defined as the work done in moving a unit positive charge from infinity to that point. So infinity is this place where the electric effects cannot be influenced by the central charge. Potential is denoted by symbol V and its unit is volt. A potential of 1 volt at a point means that 1 joule of work is done in moving 1 unit positive charge from infinity to that point. Since the unit of charge is coulomb, so we can say that a potential of 1 volt at a point means that 1 joule of work is done in moving 1 coulomb of positive charge from infinity to that point. A more common term used in electricity is, however, potential difference, which we can discuss now. Potential difference or the difference in electric potential between 2 points are the same thing. The potential difference between 2 points in an electric circuit is defined as the amount of work done in moving a unit charge from one point to the other point. So electric potential difference denoted by V is equal to work done divided by the quantity of charge moved. If W joules of work has to be done to move Q coulombs of charge from one point to the other point, then the potential difference V between the 2 points is given by the formula V is equal to W, that is the work done, divided by Q, where W is the work done and Q is the quantity of charge moved. The SI unit of potential difference is volt. Which is denoted by the letter V. The potential difference is also sometimes written in symbols as PD. The potential difference between 2 points is said to be 1 volt if 1 joule of work is done in moving 1 coulomb of electric charge from one point to the other. Thus, if 1 volt is equal to 1 joule per coulomb, we say define the potential difference. So once again, the potential difference between 2 points is said to be 1 volt if 1 joule of work is done in moving 1 coulomb of electric charge from one point to the other. So that is how we define 1 volt. The potential difference is measured by means of an instrument called voltmeter. The voltmeter is always connected in parallel across the 2 points where the potential difference is to be measured. So voltmeter measures the potential difference, and in a circuit it is always connected parallel. For example, we have a conductor AB, such as the resistance wire, which is the part of a circuit, and we want to measure the potential difference across its ends. So one end of the voltmeter V is connected to the point A, and the other end to the point B. We can read the value of the potential difference in volts on the dial of the voltmeter. A voltmeter has a high resistance so that it takes a negligible current from the circuit. The term volt gives rise to the word voltage. Voltage is the other name for potential difference. It is time to wind up this session, and the next session we will discuss mainly electric current, its direction, the measurement, electric circuit symbols and circuit diagrams. If you haven't subscribed yet, subscribe and don't forget to click the bell button so that you will get notified whenever a new video is added.